In this video, we shall be solving a problem involving the drift velocity. I have explained what this drift velocity is. For instance, if this is a conductor, a wire, so the velocity of these electrons that are contained in this wire is the drift velocity. So this problem is asking us to calculate the drift velocity of the free electrons in this copper wire of cross-sectional area A of this magnitude 1 millimeter square. When the current flowing through this wire, let's say this is the direction of the flow of the current, when the current is 2 ampere, and the number density, which is the number per unit volume, or the number of free electrons, is given as 1 times 10 to the power of 29. So from our previous video, we found that to calculate current in a wire of cross-sectional area A, we use this formula that I equals NAV, then we have Q or E. All right. Now, if you watch, we are asked to find the drift velocity. So we shall be making VD the subject of the formula. So to make VD subject of the formula now, we now have, this is I upon, this is I for current, upon, this is N A Q. And we should note that the value of I, the value of A, the value of N has been given. This Q, we are talking about electron. The charge in an electron or on an electron is given as 1.6 times 10 to the power of minus 19 coulomb. So this is the magnitude of charge in an electron. So we are considering the magnitude. So this is 1.6 times 10 to the power of minus 19 coulomb. So we'll be replacing here. So we will now notice that I now is 2 ampere upon N is 1 times 10 to the power of 29, and A is 1 millimeter square. So we're not going to use it that way. Of course, we know that 1 millimeter, of course, millimeter means 10 to the power of minus 3 meter. So this is milli, 10 to the power of minus 3. So if we have it as millimeter times millimeter, we have millimeter square, just as we have in this case, this is millimeter square, just as we have here. So it implies now that we can have something like this. This is 10 to the power of minus 3 meter times 10 to the power of minus 3 meter. And we now have 10 to the power of minus 6 what? Meter square from the law of indices. So why are we doing this? Area is in meter square. Of course, it is just description of two lengths. And of course, we know that the fundamental unit of the derived unit of length, the fundamental unit of length is meter. So of course, area is a derived unit of length. So it should be in meter square. So we shall be making use of this in calculating now. So 1 millimeter square is, so we have the area now as 1 times 10 to the power of minus 6 millimeter square. And that is what we shall be using to complete the solving of this problem. So going further, we now replace the value of this area. So we say 1 times 10 to the power of minus 6. Okay, of course, you know it's a meter square now. The electron, so the magnitude is 1.6 times 10 to the power of minus 19 coulomb. So if we do this math, we now have that our VD, V subscript D, which is the drift velocity, is 1.25 times 10 to the power of minus 4 meter per second. If you have enjoyed this video, give it a like, share it with your friends, and subscribe if you have not, so that you get updated when we post our videos. Thank you and have a wonderful day.